Hello everyone, I'm doing a practice problem on how to find volume either using spherical or cylindrical coordinates. Because one of the big things about finding volume is knowing whether or not to, like what coordinate system to use. So let's look at the problem. So we're asked to find the volume of a region bounded below by z equals x squared plus y squared and above by x squared plus y squared plus z squared equals 2. So there's a couple different ways in which we can do to solve this. We can actually either use spherical or cylindrical, but I believe it is easier to use cylindrical when looking at that we have z equals x squared plus y squared. Because that's something I feel like is easier to understand as a cylinder. Because as we go up in each increment of z, we create a circle instead of seeing it as some row being rotated around. Because even though we do have a sphere, we don't necessarily have to use spherical. So I'll go ahead and start drawing out the boundary. So if it's bounded below by z equals x squared plus y squared, that means that we're going to have a parabolic shape cone. In both the xz plane and yz plane. The reason that I know that is because if you look at just the zy plane or just the zx plane, one of them would be 0. So if we're looking at just the zx plane, we have something that looks like this. Then and y would be considered equal to 0. So we say z equals to x squared, which is almost about the same as y equal to x squared, and z's take the place of y, and we know that this shape, it looks like this. So it's easy to say that we have a parabolic cone or a paraboloid, and it's bounded above by x squared plus y squared plus z squared equal to 2. And we know that it is a sphere because it has each component squared. You can even recognize it as r squared plus z squared equal to rho squared, or just recognize it as x squared plus y squared plus z squared equal to rho squared, with rho actually being square root of 2. So we have a sphere on top of our paraboloid. So we can draw a shape like that. So this right here is z equal to x squared plus y squared. So top is x squared plus y squared plus z squared equal to 2. So like I said, we can use either cylindrical or spherical. I like using cylindrical, which requires we use cylindrical implies that we use z, r, and theta. So I have to translate all of these into terms of z, r, and theta. Another thing why I think this is easier to do in cylindrical is the angle for phi. I feel like is harder to determine with this kind of graph, z equal to x squared plus y squared. So I highly advise you use cylindrical whenever you see something as like a paraboloid or anything like that. I feel like it's always easier. Typically, you'll only see spheres when it's asked for spherical, but I mean, you can use either. You just have to use your intuition to figure out what you think is easier for you, or they'll even tell you which one to use. So when we get all of these equations into terms of z, r, and theta, we can say that z equal to x squared plus y squared really equals r squared. And we can say that x squared plus y squared plus z squared equal to 2 is really r squared plus z squared equal to 2. So I'm going to erase this. So now you have this region I have to find the volume of. But before we do that, it would be like they'll prompt you to do this, but like graph what it looks like in the y-x plane. Because if you're going to use your r, like use like for a radius, you have to know what your r is going to be. So in order to find out which your r is going to be, like looking at top, so we know it's going to be a circle. Oh man, it's a poor circle. Let me just insert one. Yeah, good stuff. The reason why we know it's a circle is because we have both a sphere and a cylinder when looking at top. Like it's z equal to x squared plus y squared, which is you can essentially write as r squared equal to x squared plus y squared. So it is a circle. But we need to find out what the radius is. So in order to find out the radius, we can put in. So if we have essentially r squared plus z squared equal to 2 and z equal to r squared, we can then substitute z in for r squared here. So we say z squared plus z and subtract 2 from both sides equal to 0. So then we can my god, I forgot the word for this. Foil it, or not foil it. Factor. Oh my god. So if we, and with this we get z plus 2, z minus 1. So it can't be z plus 2, because that means z would equal negative 2. And z can't equal negative 2 if it's bounded below by z equal to x squared plus y squared and above by the sphere x squared plus y squared plus z squared equal to 2. So we have to use z equal to 1. That means it's going to be z equal to 1 at this boundary line right here. So that means that at this point, at what the line that you see, the outermost line in the circle on the y-x plane is at z equal to 1. But what the r is will be, you can plug into either equation. I'll plug it into z equals r squared, which also means that this is going to be r equal to 1. All right. So now we know everything that we need to know in order to find volume, we can start with our triple integral. Alright, so with our triple integral, we must have, whenever we use cylindrical and we do a triple integral or any integrals with r and theta, we have to include r. So we're really doing, so volume would equal the triple integral. Hold on, I'm going to do a little better. Yeah, close enough. Alright, z, r, and theta. So that's the order you typically have to do. I'm not sure if you can do it the other way, but I've always used z, then r, then theta. But when we do this, volume will equal to dz, r, dr, d theta. We have to include the extra r every time we use r. So in order to solve for our z, we can shoot an arrow in the positive z direction. So we enter at the bottom surface, z equal to r squared. Then we exit at the top surface, z squared equal to 2 minus r squared, which we can say is z equal to square root of 2 minus r squared. And it's a positive square root because it's in a positive region for z. So it enters z equals r squared, and then exits the square root of 2 minus r squared. And then r, we would just go from the origin of the y-x plane and project it outward. Oop, my bad. So we start off at r equal to 0. and then exit at r equal to 1. And then for theta, we go from the positive x-axis and just go around a circle until we hit all of the different surfaces. Since it goes around in a perfect, and like a complete circle, it just goes from theta equal to 0 to 2 pi. So now we have our limits of integration. We can now integrate it. So the integral of z will, the integral for dz would just be z. So we can say this is the integral from 0 to 2 pi, from 0 to 1, of z r squared to the square root of 2 minus r squared, r d theta. Then this would equal 0 to 2 pi, 0 to 1, of the square root of 2 minus r squared, all times by r. So that would be r, and that would be r cubed, dr d theta. So the reason why the r was important is because now it gives us a du for our radical, because we couldn't integrate this without having another r on the outside of the radical. So now when we integrate r, we get that it equals from 0 to 2 pi times, and it's going to be 2 minus r squared to the 3 halves, and we're going to divide by 3 halves, so we multiply by 2/3, and also divide by -2, since that is the derivative of the inside. Now minus r to the 4th over 4 for the r cubed, and this is all going from 0 to 1 d theta. So then this will equal, I cancel out these two, so I have a negative third, 0 to 2 pi, negative third of 2 minus 1 to the 3 halves, minus 2 minus 0 to the 3 halves, minus 1 to the 4th over 4, so that's 1/4 minus 0 theta for all of this. Then this would equal 0 to 2 pi, negative 1/3, and that would be 2 minus 1 would be 1 minus 2 to the 3 halves, which would be 2 radical 2 minus 1/4. And what we could do is just find a common denominator, so multiply this by 3 over 3, multiply this by 4 over 4. So we, and I can't forget about my d theta. So this is from 0 to 2 pi of negative 4 plus 8 radical 2 minus 3 all over 12 d theta. And we simplify this a little bit further to where this becomes a -7. All right, and now I can do the last part of the integration. So this is just a number with d theta. So the integral of this would be 8 radical 2 minus 7 over 12 theta. From 0 to 2 pi. And it's going to be 2 pi minus 0, so we're going to get 8 radical 2 minus 7 over 12 times 2 pi, which will equal 8 radical 2 minus 7 over 6, all times by pi. So the main thing to take away from here is how to figure out whether or not to use cylindrical or spherical. Typically you can use either, but there's always an easier way. Whenever you have the option to use cylindrical, I would definitely do that, unless it's just spheres. Then it'd be smarter to use spherical, or they might also prompt you to use either cylindrical or spherical. And knowing how to translate from rectangular to spherical, or spherical to cylindrical, or and all the different three forms you can have it as, and also how to find the limits for each one. So in this case, I only did it for cylindrical, but it's important to know how you get it. So like for the Z, just shoot an arrow straight up to see what you go in and go out of in your region. For your R, you always start from the center and go outward, and so you hit the outermost region. Like you might also have two circles. So if you're going out, and this is R equal to 1, this is R equal to 2, then your limits will be from R equal to 1 to R equal to 2. But if there's no inside circle, then your R equal to 0, then 2 pi is always going to be how much of this object is rotated around the Z axis. So you look at it, you can see it in the Y-axis plane, so you're essentially looking down from the positive Z, and you see that, and for this case it's at 0 to 2 pi because it encapsulates the entire all 2 pi radians. Yeah, if you have any questions, don't go ahead and comment below. I gotta try to make these videos to give you all more time to understand what's going on, and see the step-by-step process. I know I'm not perfect, but I try to give you all as many resources as I can to help you to understand what's going on and how to problem solve through some of the issues. Hope this helps. Please give me feedback if you think there's ways for me to improve on doing videos. I know I'm probably monotone, or I pause a lot or something like that, but this is something I have to get better on my own. But please let me know. Thank you.